Okay, here we go. All right, let's have a look here. Find the slope of the tangent to that circle at that point, and hence on the circle, and hence deduce that the equation of the tangent to the circle at that point is that. Okay. So first we'll get the derivative. So that's 2x plus 2y dy dx plus 2g plus 2f dy dx equals 0. So I could rearrange that and get dy dx equals minus 2x minus 2g over 2y plus 2f. So that means dy dx, that's going to be the m, will just be at the m is dy dx at the point x1, y1. So I cancel all the 2's, take the minus out actually. So that's x1 minus y1 over, no it's not, Stephen, be careful. It's x1 minus g over y1, x1 plus g, I took the minus out, over y1 plus f. Okay, so the equation of the line, which is the tangent here, is y minus y1 equals m times x minus x1. I'll cross multiply, so that's y minus y1 times y1 plus f equals x1 plus g, and I'll put the minus in the second guy, x1 minus x. So multiplying out, I'll have y1 plus fy minus y1 squared minus y1f equals x1 squared minus x1x plus gx1 minus gx. Shall take everything to the left. So let me just see what I've got here. I've got xx1 and I've got yy1, and then I'll take a g out, and the g is coming out of this, which would leave me with x minus x1. Oh, sorry, now to be careful, because that would be x minus x1. So because that's a plus, makes me feel like I've made a sign mistake. Plus f times y minus y1. Yeah, okay. No, not actually a sign mistake. Equals x1 squared plus y1 squared. I won't write everything down again on the left, just write dot dot dot. But what I'll do is I'll add to both sides a 2gx1, a 2fy1, and a c. And that's an x1 squared plus y1 squared plus 2gx1, etc., etc. And the reason I did that is because on the right now I'll get this equation, which will be 0. But then on the left I have some extra terms. This 2gx1 can get added into this guy, so it'll be minus gx1 plus 2gx1, so that's what corrects the sign then. So you'll be left with xx1 plus yy1 plus gx plus x1 plus f y plus y1, and then there's an extra c on the right. So the trick at the end was to add 2gx1, 2fy1 and c to both sides. That was the trick, and then you get exactly that. Okay, So I've proved that. That's great. Now on to the next part. If the circle x squared plus y squared touches both axes, prove that g squared equals f squared plus c, and hence find the equation of the two circles which touch both axes and which contains the point A to A. Okay, so for a circle to touch both axes, could be like that. Actually, could be like that. Could be like that. Could be like that. It's 4 possibilities, huh? So either here, it's on the center's on that line, which means that would be centered at or here at minus or, or here at minus or here at or minus or. So yeah, it's basically at plus minus or, because minus plus, minus minus, plus plus, plus minus. Yep, that's all the possibilities represented there. Which is equal to plus minus g plus minus f. So that means that should be on the circle. No, it doesn't, sorry. That means the center. The or is plus minus, or is, okay, that's not helping actually, I realized. All right. Okay, let's have a think now. I know that the C, we can say that the r squared is equal to g squared plus f squared minus c squared. But the center is at, so actually this does help. Center is at plus minus or, so that means that g has to equal plus minus or and f has to equal plus minus or, which means g squared equals r squared and f squared equals r squared, which means g squared equals f squared. So I've shown that. Now I need to show that that's the same as c though. So if I sub that in, I can get f squared equals f squared plus f squared minus c squared, which means that, it's not c squared, just c, which means that c equals f squared. Oh, okay, there you go. So that's it done now. So I've shown that g squared equals f squared and c is equal to f squared. So I've shown that g squared equals f squared, which is equal to c. Okay. And hence find the equation of the two circles which touch the axis and which contain that point. So the circle is going to be x squared plus y squared plus, now do I want to replace the g and the f, because g, f and c, so it kind of is making me feel like maybe I should have like instead something like but it's going to be a plus minus. Let's just sub in the point first. So it's going to be a squared plus 4a squared plus 2ga plus 4 fa plus c equals 0. But how can this help me right now? Let me pause for a few seconds. Okay, just needed 10 or 20 seconds of silence to think. So I think I can make an equation here, and then I can make a couple more equations, and maybe I can solve the system. So let's see, that's 5a squared plus 2ga plus 4fa plus c. That's one equation. I also know that g squared equals f squared. That's a second equation. And then third equation, I know that g squared equals c. And I know f squared equals c. So yeah, maybe I should just do it. I didn't really want to have roots in here, but maybe I should. So I know the g and the f I can replace by root c. So, and I'm not solving for a. It's a constant. So, okay, I will just do it. I was reluctant, but I'll just do it. 5a squared plus 2 root c a plus 4 a root c plus c equals 0. So that's going to be c plus 6a root c plus 5a squared equals 0. And that is a quadratic in root c. You can see it if you say let root c equal to u. Then what you'll get is u squared plus 6au plus 5a squared equals 0. So that's going to be u plus 5a and u plus a equals 0, because that'll make u squared, 5a, 1a, 6a. Yeah, okay. So that means u, which is root c, equals minus 5a or minus a. This only makes sense if the a is negative. Don't know. Let's continue. Well, I guess actually no, that's actually okay, because it's ultimately the c that we want, not root c, so I shouldn't worry about that. So that means c equals 25 a squared or a squared, which means then f would equal the root of c, yeah, plus or minus 5a, and then g would equal the same thing, plus or minus 5a. Okay, so I have f, g, and c. So we might just want to think carefully about the signs though. So the circle is going to be x squared plus y squared. Now it does say actually the two circles, so the only issue is, do I go with plus, plus and minus, minus? When c is 25a squared, f could be plus or minus 5a. X squared plus y squared plus, then the g also could be plus or minus 2, couldn't it? There's a bit of sign ambiguity here I'll have to figure out. Plus or minus 2g, that's 10a. X plus or minus, why did I write 5 there? Sorry, I was looking. It's just a. Plus or minus 10 or 2ax plus or minus 10ay, and then the c no, I have to be careful. I'm not pairing them off correctly. Because the first possibility here, it's like this. So I should have written here g equals plus or minus 5a, and then here f equals plus or minus a. So it's either going to be x squared plus y squared plus 2g. So that's plus or minus 10a x, and then the f plus or minus 10a y, and then just plus 25a squared equals 0. And then the other one is x squared plus y squared plus or minus 2a x plus or minus 2a y plus a squared equals 0. So here's the dilemma. Do we go with the plus or do we go with the minus? Or does it not matter? Because remember at the start I said 4. There's 4. This touches xy, this touches xy, this touches xy, this touches xy. And the point A, A2A would be like, could be here, if A is positive. And if A is negative, it'd be here. So actually I only want these two circles. So this one here, yeah, okay. So actually I do have to delete here. Okay, I need, for this to make sense, I need the A to be negative. So if the A is negative, the centers could be minus 5A, minus 5A, if we take the first one here and the pluses. Then if we take the negatives, it would be, and that's okay, or it could be minus 5A, 5A, or it could be 5A minus 5A, or it could be 5A, 5A. So that one there would be positive, negative, so that's a no. That one there would be negative, positive, so that's a no. And that one there would be negative, negative, so that's okay. So the signs have to be the same. So both plus or both minus. But then I can do the same logic for the second one. So that's a good question. I'm thinking about it a lot. It's got to be something mathematically wrong. Like here, the discriminant of this should be positive. Let's have a look. 36a squared minus 4ac. B squared minus 4ac. Yeah, it is always positive, so it's not that. Got to make sure the radius is positive. Is the radius positive for both? So the radius is equal to the square root of f squared. So that would be 100a squared plus 100a squared minus 25a squared. And then for the other one, it'd be the square root of 4a squared plus, oh, actually I have that wrong because it's, ignore the 2, so be just a squared plus a squared minus a squared. So that's okay. And the other one would have been 25. Yeah, so that would have been okay as well. So yeah, actually I have 4 solutions, not 2. Oh, the question's quite clear about it. Find the equations of the 2 circles. I think there's 4 answers here. I think there's 4 answers here because I'm able to draw 4 answers. Yeah, I think there's. I'll definitely graph this one tomorrow. Definitely going to do that. Okay, tangents are drawn to both these. They're drawn to both these circles at the point A, 2A. Investigate if the distances of the origin from these tangents are equal. Okay. Got 4 circles and we have the point A, 2A, whatever that is. Like, let's just say it's here or whatever. Tangents are drawn to both these circles at that point. Investigate if the distance of the origin from these tangents are equal. Well, okay, so it's tangent, and then you want to get the perpendicular distance. But there's going to be 4 perpendicular distances for me. Thankfully, it's to the origin. The 0, 0 will simplify the calculation. Okay, so my 4 circles are x squared plus y squared plus 10ax plus 10ay plus 25a squared equals 0. X squared plus y squared minus 10ax minus 10ay plus 25a squared. X squared plus y squared plus 2ax plus 2ay plus a squared equals 0. And then x squared plus y squared minus 2ax minus 2ay plus a squared equals 0. And then we have now 4 lines. So using our tangent formula here, let's get the first one. It'll be x1. So that will be ax plus 2ay plus g. And remember that g is just half the coefficient. So that would be plus 5a x plus a plus 5a y plus 2a equals 0. Okay, so that's going to be 6a, 5a and 5a, 6ax plus, but you know what, actually, because the x and the y is going to be 0 and the distance formula is not going to matter, 2a, 5a, times y, 7a, and then the constant part would be plus 5a squared plus 10a squared equals 0. So the distance, the perpendicular distance, be all over square root, and then this would be 15 a squared, and this would be 36a squared plus 49a squared. Now if I was to change the sign, so that would mean on the f and the g, so that would become minus, and then that one there, on the f and the g, sorry, so that would become minus and minus, or d equals square root over, okay, so minus 5a, so that would make ax minus 5ax, so that would become then a minus 4a. Then the y would be 2ay minus, so that would be minus 3ay. Why did I say 7 there? Gonna redo this. And actually, I don't like the tangent formula the way it is because I want to clean it up. So the formula is going to be x1 plus gx plus y1, and then plus f, and then plus c plus gx1 plus fy1 equals 0. So that means the distance, the perpendicular distance to the origin, is going to be the absolute of that line over the square root of x1 plus g squared plus y1 plus f squared, the line at 0, 0, which actually just is going to leave you with the piece at the end. C plus gx1 plus fy1. Okay, so the four distances are distance 1, distance 2, distance 3, distance 4. Might not have space there. Distance 1. x1 plus g. Oh, actually, we know the x1 is a, so I might as well just get rid of that. A and 2a. There we go. And then on the top, that'd be ag plus 2af. Okay, so for the first one, it's 5a, 5a. 5a, 5a. So that'll be 5a squared plus 10a squared of the square root 5a, 6a squared plus, and then 7a squared. Okay, the second distance is going to be ag minus 5a, so that's going to be minus 5a squared minus 15a squared all over the square root of a minus 5a, so that's minus 4a squared, and then 2a minus 5a is minus 3a squared. Okay. And now space, distance 3. So it's going to be AA this time. So that's going to be a squared plus 2a squared all over the square root AA 4a squared plus 2a plus a 3a squared. Okay, so distance 3 is the same as distance 2, so I'm going to guess that distance 4 would be the same as distance 1. A g minus a squared minus 2a squared square root a plus g. Interesting. A plus G is 0. And then 2A plus F. So that's 2A minus A. So that's A. 0 squared and A squared. 2A plus F minus A. Interesting. Okay, so it would seem that only distance... Oh no, distance 3 isn't the same because the top... So none of the distance are the same. No, distance... None are the same. So it's a no. Hoo-wee, as Mr. Mises, was that Mr. Mises would say. Yeah, okay. This is the hardest circle question I've seen, and I think it's complicated because I'm not exactly sure which circles to choose. Of my 4 answers, there's only supposed to be 2 of them, and I'm pretty sure that the distances aren't the same, but I'm definitely gonna do this one tomorrow on the software, and I'm going to discover what have I done wrong, what have I done right. Maybe the question's wrong. I doubt that, though. These things usually aren't wrong. Okay, this is, yeah. I've never spent this long on a circle question before. I must be missing something profoundly obvious. Or this is the hardest circle question ever. Wow, okay. Graphing this tomorrow. Hopefully that'll shed some light on the situation.